January 1936, Detroit, Michigan. On the General Motors assembly line in Flint, a Cadillac body shell moved slowly past Station 14. A worker lifted his pneumatic screwdriver, positioned it against a trim panel, and squeezed the trigger. The driver spun. The screw seated perfectly. No slip, no scratch, no damage to the freshly painted surface. For the first time in American automotive history, a power tool had driven a screw without destroying the work. The worker moved to the next fastener, then the next. 40 screws in 4 minutes. What had once taken skilled craftsmen 15 minutes of careful handwork now happened in a fraction of the time. And not a single gouge marred that gleaming Cadillac body. This is the documented story of how a struggling inventor from Portland, Oregon, solved a problem that had plagued American manufacturing for 3 decades. How a businessman named Henry Phillips turned a rejected patent into a $500,000 manufacturing revolution, and how a simple cross-shaped groove in a screw head made the modern assembly line possible. The slotted screw had been the standard fastener since the 15th century, a single straight groove across the head, driven by a flat-blade screwdriver. Simple, ancient, and by 1930, completely inadequate for industrial mass production. The problem wasn't the screw itself. The problem was power. When Henry Ford introduced the moving assembly line in 1913, everything about automobile manufacturing accelerated. Workers no longer walked to the car came to them. Efficiency soared. Production time for a Model T dropped from over 12 hours to just 93 minutes, but certain operations refused to cooperate. Screws, specifically. Slotted screws required precise alignment. The flat blade had to sit perfectly centered in the groove before applying torque. With hand tools, a skilled worker could feel when the blade seated correctly. But power tools couldn't feel anything. They just spun. When a pneumatic screwdriver's blade slipped from a slotted screw, it didn't stop. It kept spinning. And that spinning blade would gouge across painted surfaces, scratch chrome trim, and damage the work faster than the human hand could react. Assembly line supervisors called it cam-out. Workers called it something less printable. The mathematics were brutal. A 1930 Cadillac required approximately 700 screws to assemble. If even 5% of power-driven operations resulted in slippage, that meant 35 potential scratches per vehicle, 35 opportunities for a spinning screwdriver to destroy finished work, 35 reasons why skilled workers still had to hand-drive screws in critical locations, slowing production to a crawl. The automobile industry needed a screw that couldn't slip, a screw that would center the driver automatically, a screw that could handle power tools without destroying everything it touched. By 1930, they had been looking for 20 years. The Canadian solution arrived first. Peter Limburner Robertson, a salesman from Hamilton, Ontario, cut his hand badly in 1906 when a flat-blade screwdriver slipped during a product demonstration. That injury sparked an idea. What if the screw head had a socket instead of a slot? What if the driver fit into the screw rather than across it? Robertson patented his square socket design in 1908. The concept was elegant. A tapered square recess in the screw head, a matching square-tipped driver that fitted snugly inside. The driver couldn't slip sideways because the walls contained it. Self-centering, secure, revolutionary. Fisher Body Company, which manufactured wooden car bodies for Ford Motor Company, began using Robertson screws in their Canadian plants by 1915. The results were remarkable. Workers could drive screws one-handed. The driver stayed socketed even when working overhead or at awkward angles. Assembly time dropped significantly. Henry Ford noticed His Windsor, Ontario plant was producing Model T bodies for $2.60 less per vehicle than American plants using slotted screws. On a car that retailed for $390, that savings was substantial. Ford wanted Robertson screws for his American operations. He wanted them badly. But he also wanted control. The meeting in Detroit was brief. Ford offered Robertson an exclusive contract. Ford's factories, Ford's specifications, Ford's oversight of manufacturing. Complete control in exchange for the American market. Robertson refused. The Canadian inventor had already watched one overseas licensing deal collapse. He had opened a plant in Britain before the First World War, only to see it fail when he couldn't maintain quality control from across the Atlantic. He wasn't about to surrender his invention to American corporate interests, his screws, his terms, his way. Ford walked away, and because Ford controlled Fisher Body's contracts, Robertson lost that customer too. 1/3 of his business gone in a single meeting. The Robertson screw would remain a Canadian product. To this day, it dominates hardware stores north of the border while remaining virtually unknown in the United States. Canadians call Americans foolish for using Phillips screws. Americans have mostly never heard of the alternative. But in 1930, Ford still needed a solution. American assembly lines still struggled with slotted screws, and somewhere in Portland, Oregon, a man named John P. Thompson was about to file a patent that would change everything. Almost nothing is known about John Thompson. Census records indicate he worked as a bank cashier and in real estate before moving to Portland from Bismarck, North Dakota, around 1920. City directories listed his occupation as furnished rooms and laborer. A 1939 newspaper article described him as an auto mechanic. What we know for certain is this. On some date in 1932, Thompson filed United States Patent Number 1,908,080 for a screw with an innovative cruciform groove. The following year, he filed a companion patent for a matching screwdriver. Thompson's design looked similar to Robertson's in principle. Instead of a slot, a recess. Instead of a blade, a shaped tip. But where Robertson used a square, Thompson used a cross. 4 slots radiating from a central point, creating an X-shaped cavity that would grip a cross-tipped driver. The concept had actually existed for decades. English inventor John Frierson had patented a cruciform screw head in 1884. But like many 19th-century innovations, Frierson's design proved impossible to manufacture economically. The complex recessed shape required machining operations that made mass production impractical. Thompson believed he had solved the manufacturing problem. He hadn't. When Thompson approached American screw manufacturers with his patent, they examined his design and delivered the same verdict they had given every cruciform inventor before him. Impossible. The punch required to stamp a cross-shaped recess into a screw head would destroy the head. The metal would deform. The tolerances were too tight. The idea was sound. The manufacturing was fantasy. Thompson made the rounds for months. Every major screw company in America turned him down. The design couldn't be made. End of story. By 1935, Thompson had given up. He sold his patents to an acquaintance in Portland named Henry F. Phillips. Henry Frank Phillips was born June 4, 1889, in Bolivar, Missouri. By the 1930s, he had established himself as a Portland businessman, serving as managing director of the Oregon Copper Company, a mining operation in eastern Oregon. Phillips wasn't an engineer, he wasn't an inventor, but he understood business, and he understood that Thompson's cruciform screw design solved a problem worth billions of dollars to American industry, if the screw could be manufactured. In 1933 or 1934, Phillips formed the Phillips Screw Company in Portland not to make screws but to license the design and collect royalties. He immediately began approaching the same manufacturers who had rejected Thompson. They rejected Phillips, too. Same design, same manufacturing impossibility, same answer. But Phillips was persistent in ways Thompson hadn't been. He refined the design, making the recess shallower, adjusting the angles, modifying the geometry to work with existing manufacturing equipment. Over the next several years, he filed 6 additional patents covering improvements to the original Thompson concept, and he kept knocking on doors. Eugene Clark had recently become president of the American Screw Company in Providence, Rhode Island. American. Screw was one of the oldest and largest fastener manufacturers in the country, founded in 1860 with capital of $1 million. They employed 2,500 workers and produced 40,000 gross of wood screws per working day. When Phillips walked into Clark's office, he found something he hadn't encountered before: interest. Clark saw what others had missed. The Phillips screw wasn't just another fastener. It was a solution to the assembly line problem that was costing American manufacturers millions of dollars annually. If American Screw could figure out how to make it, they would own the market. Clark committed $500,000 to solving the manufacturing challenge. In 1936 dollars, adjusted for inflation, that investment exceeded $8 million in modern currency. American Screw would develop the tooling, the processes, and the machinery required to mass-produce Phillips screws. In exchange, they would become the sole licensor of the manufacturing method. The engineering team in Providence attacked the problem. The fundamental challenge was creating a punch that could stamp a precise cruciform recess into steel without deforming the screw head. Traditional punching techniques applied force straight down. The metal had nowhere to go except sideways, bulging and cracking around the recess. American Screw's solution involved controlled metal flow. Instead of fighting the displaced material, their process channeled it into specifically designed spaces within the die. The punch itself was engineered to create the recess in stages rather than a single strike. These manufacturing innovations were themselves patented, creating a double layer of intellectual property protection. By late 1936, American Screw had Phillips screws ready for industrial testing. They needed a customer willing to try an unproven fastener on a production line. General Motors said yes. The Cadillac division agreed to test Phillips screws on their 1936 model assembly line. If the screws worked, GM would adopt them across their manufacturing operations. The first Phillips screws to enter mass production drove into Cadillac trim panels in late 1936. The results exceeded every expectation. Self-centering worked exactly as designed. Workers could position a pneumatic driver roughly in the vicinity of the screw head, and the cross-shaped bit would slide into the recess automatically. No careful alignment required, no feeling for the correct position. Point, squeeze, done. Cam out vanished as a problem. The Phillips recess gripped the driver from 4 directions simultaneously. The bit couldn't slip sideways because the walls of the cross prevented lateral movement. Under normal operating conditions, the driver stayed socketed until the screw was fully seated. But Phillips had built in something even more valuable: intentional cam-out. The geometry of the Phillips recess featured slightly tapered walls. As torque increased, the driver experienced increasing outward pressure. When torque exceeded a certain threshold, the tapered walls would push the driver up and out of the recess rather than allowing it to strip the head or break the screw. This controlled cam-out was a feature, not a bug. In an era before automatic torque limiters, power tools would happily keep spinning until something broke. With slotted screws, that meant stripped heads and damaged surfaces. With Phillips screws, the driver would pop out when the screw was tight enough, preventing over-tightening automatically. The Cadillac test generated immediate adoption. By 1937, General Motors had standardized Phillips screws across multiple divisions. Other Detroit automakers followed within months. The railroad industry adopted Phillips screws for equipment assembly. The aviation industry recognized that controlled cam-out was perfect for aluminum aircraft construction, where over-tightened screws could strip soft metal threads. By 1940, 85% of American screw manufacturers had secured licenses from the Phillips Screw Company to produce the design. The Phillips Screw Company itself never manufactured a single screw. They collected royalties. In 1940 alone, the company grossed $77,421 almost entirely from licensing fees. Adjusted for inflation, that exceeded $1,300,000. The Phillips screw had conquered American manufacturing in less than 5 years. The technical advantages were profound. A 1936 Phillips patent noted that only 2 sizes of Phillips drivers were required for screw sizes number 5 through number 16. Slotted screws required 6 or more driver sizes to cover the same range. Fewer tools meant simpler inventory, faster training, and reduced costs. Assembly times dropped dramatically across industries. Tasks that required careful handwork with slotted screws could now be performed with power tools. One documented estimate suggested that Phillips screws reduced automobile assembly time by nearly 2 hours per vehicle. At Ford's scale of production, that translated to hundreds of thousands of labor hours saved annually. Quality improved alongside speed. Scratched paint, gouged surfaces, and damaged trim had been accepted costs of power-driven assembly. With Phillips screws, those costs disappeared. Final inspection rejection rates dropped. Warranty claims for cosmetic damage declined. The simple cross-shaped recess eliminated an entire category of manufacturing defects. When America entered the Second World War in December 1941, the Phillips screw became a weapon of industrial warfare. Aircraft production demands precision fastening at extraordinary scale. A Boeing B-17 Flying Fortress contained thousands of screws securing aluminum skin to structural, endy frames. Each screw had to be tight enough to maintain structural integrity under combat conditions, but not so tight that it stripped threads or cracked aluminum. Phillips screws with their controlled cam-out were ideal. Assemblers could work quickly with power tools, and the screws themselves would prevent over-tightening. Production rates soared. Boeing and its partners produced nearly 7,000 B-17s during the war. Douglas Aircraft assembled over 10,000 C-47 transports. Consolidated delivered almost 20,000 B-24 Liberators. Every one of those aircraft relied on Phillips screws. The fastener that had revolutionized automobile assembly proved equally transformative for aircraft manufacturing. By war's end, American factories had produced over 300,000 military aircraft. The Phillips screw had enabled that production through faster assembly, fewer defects, and reliable fastening under the most demanding conditions. But success brought its own problems. The Phillips screw was so useful, so obviously superior to slotted alternatives, that manufacturers began copying the design without licenses. The distinctive cross-shaped recess appeared on screws from companies that had never paid royalties to Phillips or American Screw. Patent enforcement in the 1940s was expensive and slow. Henry Phillips fought to protect his intellectual property, But the design was too simple, too easily replicated, too valuable for competitors to resist. In 1949, Phillips lost his patent protection entirely. Courts ruled that the design had been so widely copied that it had essentially entered the public domain. The Phillips Screw Company could no longer claim exclusive rights to the cruciform recess their founder had commercialized. Henry Phillips had retired 4 years earlier, in 1945, due to failing health. He lived his final years in relative obscurity, maintaining a low profile in Portland while his invention transformed global manufacturing. On April 13, 1958, Henry Frank Phillips died in his Portland apartment at the Ione Plaza. He was 68 years old. His obituary in the Oregonian was brief. Founder of the Phillips Screw Company, honorary member of the University Club, member of the Catholic Church. Survived by his wife Nellie Helen, 4 sons, 1 daughter, and 20 grandchildren. The man who had given his name to the most widely used screw design in history received a small funeral and faded from public memory. Few Americans know that Henry Phillips ever existed. Everyone knows what a Phillips head screwdriver looks like. John Thompson, the actual inventor of the cruciform screw design, had died even more obscurely. He passed away in Portland on September 4th, 1940, years before the Phillips screw achieved global dominance. No obituary survives in major newspapers. The man who conceived the design that would fasten together. The modern world received no recognition in his lifetime. The Phillips screw didn't just change manufacturing. It changed everything that manufacturing produced. Consider what happens when you turn an ignition key. The switch mechanism contains Phillips screws. The dashboard into which the ignition cylinder mounts is secured with Phillips screws. The steering column that holds the key cylinder uses Phillips screws at multiple attachment points. Before your engine even starts, you've relied on dozens of crosshead fasteners that exist because Henry Phillips refused to accept impossible as an answer. Your smartphone contains Phillips screws. Your laptop contains Phillips screws. Your refrigerator, your washing machine, your television, your furniture, your children's toys, the light fixtures above your head, the outlets in your walls. Phillips screws hold together the fabric of modern material existence. The Phillips Screw Company still operates today, headquartered in Massachusetts. They no longer own exclusive rights to the basic Phillips design. That passed into the public domain 75 years ago. But the company continues developing improved fastener technologies, licensing proprietary drive systems to manufacturers worldwide. The Robertson screw, rejected by Henry Ford, remains the Canadian standard. 85% of screwdriver sales in Canada are Robertson square drive. Hardware stores north of the border stock Robertson screws as their primary fastener. Canadians who move to the United States are perpetually frustrated by the Phillips screws that dominate American retail. Whether Robertson is actually better than Phillips depends on whom you ask. The square drive offers more torque capacity and virtually eliminates cam-out, but the Phillips design's intentional cam-out was valuable in an era of uncontrolled power tools, and the cross-shaped driver is more forgiving of slight size mismatches between bit and recess. What's certain is that licensing strategy determined market dominance. Peter Robertson refused to license his design broadly and lost the American market forever. Henry Phillips licensed aggressively, sacrificing control for penetration, and conquered the world. In 1936, America had no assembly screw. Every fastener in industrial use was either a slotted head requiring careful hand alignment or an imported specialty item with limited availability. American manufacturers accepted scratched surfaces and damaged work as the cost of power tool operations. Within 5 years, the Phillips screw had made those problems obsolete. American Screw's $500,000 investment returned billions in productivity gains across every industry that manufactured assembled products. One small change in screwhead geometry, one persistent businessman who refused to accept rejection, one engineering team that solved a manufacturing problem everyone said was impossible. And the modern assembly line became possible. Every time you pick up a Phillips screwdriver, every time you drive a cross-head screw into wood or metal or plastic, you're using technology that traces directly back to Portland, Oregon, and Providence, Rhode Island, in the 1930s. John Thompson conceived the design. Henry Phillips commercialized it. American Screw figured out how to make it. General Motors proved it worked. The humble Phillips screw. It didn't literally save every car, but it made every car possible to build at the speed and scale that modern consumers demand. It eliminated defects that plagued early mass production. It enabled workers to use power tools without destroying their work. The cross-drive that holds the world together started with a laborer's rejected patent and a businessman's stubborn refusal to accept no for an answer. America had no assembly screws in 1936. By 1940, American screws led the world. That's what happens when impossible meets $500,000 and pure commercial determination. When a simple geometric insight meets the full force of American manufacturing ingenuity. Henry Phillips never made a screw. He never turned a lathe or operated a punch press. But he understood that the best idea in the world is worthless unless someone figures out how to build it at scale. He found the people who could solve the manufacturing problem. He negotiated the licenses that spread the technology. He built the business structure that made the Phillips screw ubiquitous. And then he faded away, his name attached to a screwdriver in every toolbox on Earth, the man himself forgotten. Turn your ignition key tomorrow morning. Your car will start because hundreds of Phillips screws hold it together, each one descended from a patent that manufacturers said couldn't be made, commercialized by a businessman history barely remembers, manufactured by an engineering process that cost $500,000 Depression-era dollars to develop. The Phillips screw didn't save every car. It did something better. It made every car buildable,